Hello, everyone. Welcome to one of the first Lunch and Learns. Hope you're enjoying the conference so far. Today we've got Jeff Charrington and Michael McKay from Rocket Software. And I'm going to hand over to them in just a sec. Um, Jeff will explain to you how he wants this to go with interaction. But what I would like to say is please remember to do your feedback. It's really important for us, so we know what you like and what you'd like different. So I think that's all I'm going to say. I'm going to go on mute and pass over to Jeff and Michael.
Thank you so much, Anji. So, ladies, gentlemen, thank you so much for joining us. We're delighted to have this opportunity to present at the virtual GSE UK. And we certainly look forward to seeing many of you again when we return for in-person in the fall. And Michael, I don't know that I'm seeing your slide. I'm wondering if others are.
Yeah, no, here it is.
All right.
Should be seeing it now.
There we go. Thank you. So in this session, we're going to be talking about unleashing the strategic impact of hybrid cloud in mainframe organizations. We at Rocket are very committed to helping our customers take maximum advantage of their investments in mainframe technology while embracing all of the things that cloud can offer. I'm Jeff Charrington. I'm Vice President of Product Management for the Infrastructure Modernization Business Unit at Rocket, which essentially means we're the mainframe group out of all the things that Rocket offers. And I'm joined by Michael McKay, who is Senior Sales Engineer, actually there in the UK and local to your time zone. Michael, if we can proceed. We'll start talking to the content, but as I do want to ask a little indulgence on housekeeping. As Anji indicated, we'd like this to be participative. We invite questions and we want to interact with you. Let's make this a conversation as opposed to a lecture. Noting, of course, as we all are now accustomed to, this is a virtual session. What I ask is that you use the feature at the bottom of the screen of your Zoom console, just to the right of middle reactions. You'll see a smiley face. If you'd like to interject or ask a question, please raise your hand. Either Michael or I will note that, and then we'll pause and give you the opportunity to add your thoughts to the conversation, which we're very keen to do. Equally, we'll be monitoring the chat feature, and if there are questions that you don't want to voice but you'd like us to make note of, please use the chat to break in. So with that, as we proceed and we talk about the opportunities that are available with mainframe in the current environment, we do see that strategies are shifting a bit. One of the things we at Rocket found to be very useful in our conversations with our customers, our partners, and others is to ask them where they are in their stewardship of mainframe processing within their enterprise. And part of the result of that is what you see on the left side of the screen. Over the last 3 years, we've been asking, what are your plans in terms of investing in your mainframe data processing? Are you going to replace or replatform, abandon the mainframe? Are you going to continue operating as is? In other words, stable state, but no new workloads added? Or are you looking to modernize and optimize? And you can see from the results that there is a large core of those of us in the mainframe space who continue look to modernize and optimize. The mainframe still remains vital as a core transaction processing engine, as a core compressed window high-speed batch processing system. And it's in that space where we feel like there's great opportunity. While at the same time, we recognize that some customers will elect to operate as is, and we continue to support them and help them as they continue through their evolution. And there is a percentage that looks to replace or replatform. And many of us have had experience with that. And we know that some of those are successful and some of those are not. And in fact, we here in the States, at least, are beginning to see that some workloads are returning to mainframe because they are the best suited, the workloads are best suited by that highly available, highly serviceable, low latency platform. The other conversation that we have is asking why, if you are in the bottom quadrant or the bottom section of these bar charts and you're looking to replace or replatform, why are you doing it? And almost every time, certainly more than half, the conversation comes back to, we're doing this because we've been told to do this. Our senior executives or our chief officers have said, you must move off the mainframe. Many of those individuals certainly haven't had experience. They don't come from the mainframe heritage and they don't necessarily understand. And that's why in many cases, we see that there are poorly financed, poorly organized efforts to move off the mainframe that don't come to fruition and cost an organization a great deal of money before they decide that they must take another direction. Now, we don't ever want to see anyone fail, and we will support customers who want to replatform, and we'll talk a bit about that as we go forward. But we do believe that the future still is very bright for integrating the mainframe into hybrid architecture that gives the best advantages from the highly available low latency platform, along with the broad horizontal scalability, the elasticity, and some of the tools that are available in cloud that may not be as available on mainframe. I am interested, is there anybody who'd like to voice their experience? What are you seeing as you look at your enterprise and where they are headed with mainframe? Do you see reinvestment and an improved modernization and optimization?
Feel free to type in the chat if you'd like to not come up mute instead as well.
Sure. And I certainly don't mean to put anybody on the spot, just wanted to give the opportunity for someone to offer even a counter opinion. I'm always happy when somebody says, Jeff, you're just dead wrong, and here's why, because we always learn a lot in the process. Michael, next slide, please. So this is our tagline, and it is something that we believe in very, very viscerally. Modernization is inevitable. It is unavoidable. For those who want to remain competitive, we must modernize not just the mainframe, but everything that we do in terms of competing successfully in the marketplace. One of the risks of modernization is what I voiced just a moment ago. It is launching into products that disrupt the organization, that consume resources, that consume attention and management direction, that impact customers and don't lead to success. We believe, though, there is a path forward that allows for modernization without disruption. And that's what we're looking to bring to you in this conversation today. How can you take advantage of the best of what the cloud has to offer, along with your on-premise resources, particularly the mainframe, so that you do arrive at that stable and usable hybrid cloud architecture? Next slide, please, Michael.
I just wanted to point out in the chat, Colin Knight was saying that there's, I think more and more that there's less and less advocates for the mainframe. And another comment on the chat says that I've talked to customers and they say hybrid clouds are overstated without looking at the actual cost in the long run and have decided to stay on mainframe and modernize mainframe.
Well, go ahead, please, Michael.
Sure. Yeah. Just to interject, my personal opinion here, when we specifically talk about hybrid cloud, we're talking about hybrid cloud with mainframe, in that conversation as well. So you're modernizing the mainframe by uh, having hybrid cloud in the picture, whether that's offloading data to cloud that doesn't necessarily need to sit in your data center or on your mainframe disks. But it is still very much keeping mainframe as the focus for your organization, or certainly not decommissioning it, but rather using them both in tandem, getting the benefits of both sides.
And we do want to recognize the sentiment that Colin voiced, because Colin, it's absolutely unequivocal that there are fewer advocates of mainframe than there were, at least when my career started in the late 70s, the early 80s. With the advent of distributed computing and then cloud computing, there's more competition for mindshare, there's more competition for resources. And that's one of the reasons that we are so committed to supporting organizations such as GSE UK, because while there may be fewer voices advocating for mainframe, it's in forums like this that we find very compelling, very persuasive voices who are advocating for mainframe. And it's one thing that I also encourage you to take advantage of from vendors such as Rocket, and I'm sure others, is to find those opportunities to engage with the executives who perhaps uh, would be persuaded or could be persuaded to see the value, and have those of us who work with this every day and work with executives every day share what we've learned, talking not just to ourselves, but more importantly to customers like you all over the world. I have been doing this for a long time, and my thought and my experience has been that executives like nothing better than the opportunity to get some benchmarking information about what others in the industry are doing. And we, Rocket, serve over 1,000 clients, probably not every mainframe in the world, as IBM would, but very close to it. And we get into conversations that can give us keen insights into what are the mainframe executives in financial services doing and thinking? What are the mainframe executives in government doing and thinking? And that tends to be very good information to better highlight the value of the mainframe in the enterprise. Michael, if we can go to the next slide. And thank you both, Colin and Sridhar, for chiming in. We're very, very pleased to see participation, and we encourage the rest of you to do the same. So you hear our point of view. I don't know that we need to linger on this particular graphic, other than I've always loved the way it looks. I like the way it presents the idea of a peaceful coexistence between the mainframe and the cloud, and that they both have their role to play in the yin and yang of developing our architectural visions as we go forward. Michael, next slide. And here's where we focus. We do believe that there is a best of both, and we'll continue to build on that and expand on that as we go forward. We've talked about, I've already said the things that are close to my experience. I spent a good deal of my career in electronic payments and in consumer banking. And the idea of any other platform being as capable of dealing with the high-speed, real-time online transaction processing, particularly at scale, I think is naive. There's no platform better suited. As my supervisor, my boss says, Bill Buckaloo, who is president of the Infrastructure Modernization Business Unit and was at IBM for 22 years and leading their IBM Cloud initiative for the last 5 years before he joined us at Rocket. There's no platform better than the mainframe for vertical scaling, meaning how can I ramp up to handle more transactions? How can I ramp up to process more data in my batch window as my business is successful and grow? It's far easier to do that on the mainframe than any other platform available. But he continues and he says, but there is no platform that's available to us today that is as good at horizontal scaling as the cloud. And what he means by that is rapidly and dynamically increasing the number of servers that are available to do a particular job or process. It allows us to scale out workloads, and it also brings to the table some tools that are particularly well suited to things of interest to us today. As we go forward, Michael will have the opportunity to talk about the advantages of doing the very processor intensive, CPU intensive, and data intensive work of creating new machine learning algorithms for AI. AI is beginning to emerge in the marketplace as not just novel, but actually practical and commercially viable and commercially inevitable if we want to remain competitive. We can crunch all of those algorithms in the mainframe. There are things that are available that make that happen, but few of us want to invest our expensive compute from mainframe on that as opposed to our transaction processing required to run our business. It's actually much more economical and in many ways better suited to take mainframe data, copy it to the cloud in quantity, take advantage of the low price points and elasticity of cloud storage, and then also take advantage of the elasticity of cloud compute and the tools that are available in the cloud to derive our machine learning algorithms. And we'll come back to that and we'll expand on that theme as we go forward. I see Colin has interjected in the chat. Thank you, Colin. Colin says, when I looked for stats to back up the mainframe scaling ability, I found it quite hard to find true business uses showing high volume throughput. Perhaps IBM could announce some real stats in the real world to show the mainframe's true scaling. Colin, I don't have those at hand, but I will dig some of that out. It is available. There are some transaction numbers that I've seen in recent conversations that I believe are very persuasive and compelling. And I'll go back to my personal story. I've lived in the electronic payments for 25 or 30 years and have experienced what happens when a customer becomes particularly successful. The thing that I always think of is retail and the shopping season around the holidays. There are those companies that will unexpectedly have successful marketing programs, and their transaction volume will go through the roof. And with on-off capacity on demand and other sorts of offerings from IBM, they're able to quickly, easily, and transparently ramp up their processing capacity to meet that need. Whereas it would be certainly, I'm sure, a possibility on the cloud or on distributed systems, but the idea of ramping up additional servers puts more complexity and overhead into the process than we're able to achieve with microcode changes on the mainframe. And again, Colin, thank you for interjecting. Loved the conversation going on here. Next slide, please, Michael. And as we've continued these dialogues and as we've engaged with the analysts in the community, we've begun to collect some really compelling evidence. Gartner, in their survey of AI adoption, indicates that 70% of new internally developed applications will incorporate AI or ML-based models. And I think that's, again, a competitive necessity. If you're not doing it, you can be assured that your competitors are. And there are things that are happening that will make that a competitive advantage that you don't want to lose. IDC says 430% of new data captured, created, and replicated by 2025. The increase will be more than fourfold. And certainly, as we've looked at the curve of data that's being retained, that's certainly been the case. Both the certainly here in the litigious U.S., the records requirement demands of our legal departments in corporations continues to rise as they want more and more data to be available in case of litigation. The amount of data that marketing wants to retain so that it can be ingested into just what we described with these machine learning algorithm developments, so they can better predict buyer behavior, customer interaction behavior, to increase the degree of interaction and the degree of loyalty from the customers that they've retained. And McKinsey is saying 35% of the reports that businesses generate today add little to no value. Now, that seems a little orthogonal to all of this conversation, but again, Michael will have a chance to bring this right back into the conversation as we start asking you to share your experiences with the cost of storing secondary data.
Yeah.
Next slide, please. Oh, go ahead, Michael. Did you want to interject?
Yeah, no, I'll be covering that off soon.
All
And I
right.
think this is where I start
I turn it
speaking
over
to
to you,
this slide.
Michael.
Yep. Thank you.
Over to you.
So in the next kind of 3 or 4 slides, we're going to be talking about, I guess, theoretically, about how you may look to better manage your data landscape across your organization. And so we come to you with a problem here on your left-hand side, which could be that your systems and teams are siloed. You can't wait months to get visibility into your data that you have across your systems, and you would rather not rely on SMEs for insight into what can be trusted on my legacy platforms. Now, this is a really interesting conversation piece, and actually, if you have any experience with this, I would encourage you to put it into the chat. But I've spoke to a number of organizations, both in the UK banking sector and actually in the Netherlands as well, in the Netherlands banking sector over the last few weeks, um, who talk about mainframe modernization and how they're looking to take steps into uh, that space, but they're having challenges with tracking and understanding the data that they have across their whole entire enterprise. These organizations are using the mainframe, storing data in databases such as DB2, and having that information be replicated now over to distributed sites, maybe to Postgres databases, over to Kafka, over to clouds as well, maybe AWS or Azure. And they could be doing a number of different things, generating reports, doing AI machine learning type work, deriving business intelligence information from this data, right? They're doing a lot of different things. But what they're not doing, or what they're not really understanding today, is really what their data landscape looks like. You have a lot of disparate platforms, we call it. We have your mainframe on one side, you've got your distributed side, you've got your clouds, you've got a very complex environment. And so, how do you really, first of all, understand, and then second of all, trust the data that you have, right? If you were to say have a legacy application that you want to maybe expire, you want to get rid of it. How can you do that without understanding the effects of deleting that? The effects of deleting certain data sets that may or may not be important, because you don't understand how the data is used in various other things. Maybe a report somewhere that's important for someone, will go away if you got rid of X and Y data that may or may not be important. So a big, a big part of modernization in my mind, and I think Rocket really has this mindset as well, um, is really understanding your data lineage and really starting to trust your data, especially if you're moving your organization towards more of a cloud integrated environment, right? You have a very complex environment that's getting even more complex as you add in clouds and different platforms. And so you really need to try and understand your data. You need to try and understand to be able to trust your data, to help you achieve these modernization outcomes. Otherwise, you're kind of going to just be running in circles a little bit. And how can this be done? It can be done through a variety of different methods, maybe employing fit for purpose UIs that ingest and gather metadata uh, across various different disparate data sources. And then, that data is collected and visible on GUIs that data analysts will then use to understand, who's updating which data, what's getting deleted, what affects what applications or what reports getting created or whatever the case may be. It might also help you with the problem that Jeff alluded to in the previous slide, If you got 35% of your data that's potentially useless, taking up storage space, well, maybe if you understand your data a little bit more, you can be a little bit more confident in getting rid of some of that, freeing up some storage space, saving the organization some money, things like this. So it's definitely important to understand and then trust your data when looking to modernize on all aspects, but also on the mainframe as well. Nextly, it's interesting. It's an interesting conversation to talk about accessing data securely and efficiently. So a lot of organizations might look to integrate distributed platforms or the cloud with their mainframe, but they might also be worried about compliance, expenses, security is a massive point. And this is something I actually talked about this morning in my security session that I had. And that's, introducing if you think of the mainframe, generally people think of it as quite a secure platform. And so introducing applications and exposing mainframe data to a distributed world, to cloud applications, potentially can cause some sort of security concerns. So, it's important for you to manage this. I'm not saying to discourage you from doing this, because I think that it's important that you do this if you want to achieve some modernization outcomes. Um, but it's important to understand that you have to leverage kind of diverse techniques to do this, right? When we're talking about ETLing data off your mainframe or exposing it for applications, right? Maybe to make sure that you have the correct security settings in place. You have data retention periods and policies in place. You have filters to allow certain data to be ingested off platform, but not necessarily all the data, right? There's ways of managing said data to make sure that you're not overexposing yourself to any sort of risk. But it also, along this topic, sure, that's all fine and well from a security perspective, but maybe you might think to yourself, well, what is the cost of doing um, these sort of large scale operations, like your ETL operations? We've spoke to airliners in the past, in particular. We talk about, we take a lot of IMS data and ETL it off the mainframe for use for X, Y, and Z, and that's a very costly thing to do. So, you know, there's a whole conversation in opening up your mainframe to be accessed by the distributed world. But then there's another conversation in that, okay, in practicality, how can we do this and remain cost conscious as an organization? Reduce your costs. Maybe try and leverage some zip engines to save MSUs on your general CPUs, for example, things like that. So these are certainly things that Rocket as an organization are looking at, because adopting hybrid cloud is important and is the way the industry is moving towards, definitely. But doing it in a cost-effective way and a secure way is certainly something that um, is on the minds of IT leaders. Another interesting point to talk about is how to transform the kind of mindset that people have when it comes to using data. So we have a quote here on the left that more or less says, empowering data-driven initiatives while managing exponentially growing data footprint is untenable without seamless and cost-efficient way to manage the impact of my platform and reduce resourcing costs. So what we're talking about here is, again, I'll go back to our ETL example, but we can talk about it in a broader case, maybe when it comes to data replication in general, right? So a lot of organizations uh, will replicate data off the mainframe in some sort of way, or to data lake. We talked about machine learning and AI use cases for organizations, right? Even things like public clouds are getting considered by some organizations. So you have to be really certain that you're not putting, any sort of data on there that you don't want, uh, or you shouldn't really put onto it. But anyway, the point that we're really making here is that it is really a costly initiative to expose your data or to replicate your data on different platforms. And really, there are other ways of going about it rather than the standard kind of, oh, let's just ETL the data, let's push the data off the mainframe. You could kind of move data intelligently or potentially not move data at all by virtualizing the data. That could be something you could do. So the idea of data virtualization would be that you keep your data where it is on the mainframe and DB2, IMS, VSAM, sequential files, wherever it is sitting today, and you don't change any of that, but you can expose, you can virtualize and expose certain data sources or for various different distributed applications or cloud applications, things like that. So the idea is again there is really to kind of enable your mainframe to talk to and be used by the distributed world without actually needing to move your data to begin with. Keep your cost and data footprint a little bit down, and also selectively choose what you want. So rather than let's replicate all of DB2 to SQL, Oracle, and do whatever you want to do with it. Maybe you can just expose some specific data that you need for some specific use case, and you don't even need to move it. You can just issue reads, for example. This is also generally cheaper to run again, rather than moving data, right? Because you're only issuing reads. Another a topic point which is quite interesting is talking about the automation of data management processes, right? So there's a lot of data requests. And in fact, the number of data requests has really exploded, actually. A lot of organizations, especially banks, which I'm most familiar with, they're getting constantly having more and more people on their banking apps checking their account balances all the time. All these data requests are happening all the time. And as such, for an organization, you might need a way to track that this work is happening and what its impact is to your business, right? So again, using capabilities to understand workflows of data requests, right? Being able to predict the growth of data requests, going back to what Jeff mentioned earlier, talking about retail and how, Christmas period, in general, people buy more, payment systems are busier, right? How can you predict these outcomes and then how can you actually um, prepare for them accordingly, right? These are sort of challenges that you may face in a more hybrid world where your applications might actually be on the cloud side or on the distributed side, but very much ingesting mainframe data. So coming up with a frictionless process to access the data is one thing, but also being able to understand growth, impact analysis of potentially maxing out your CPU or having a very busy day, things like that is very important for a lot of organizations these days. So we have a little bit of a solution footprint here, and this is a nice picture, but I'm not really going to sit here and talk about products because that's not really what I'm here to do today. But I just want to talk conceptually about some of the things that you can do today and kind of tie it back to some of the things that I've mentioned in the previous few slides. So I'm going to put on my laser pointer and show you, okay, here is your mainframe that's sitting in your data center today. Now, you may have any number of these sort of data sources. You could have IDMS or Datacom, Atabas, DB2, IMS, VSAM files. You've got SMF, records, kicks. You've got log files, sequential files, right? Flat files, MQ, basically anything, any sort of data that you've got sitting on the mainframe. And you may have, and we'll call it cloud, but it could be a distributed world. The organization will likely have a distributed world as well. You might be using AWS or Azure or IBM's cloud or Oracle or SQL or Postgres or whatever it is. And you could have data lakes, you can have warehouses, you have streaming platforms, Kafka, MongoDB. You have all these things. And it's likely that your distributed teams are building a lot of applications here and they're scaling up the size of their databases and they're doing machine learning, AI use cases over here, and they're building their business here. But the problem that you may have is that you have a lot of really important information here, a lot of important data that could be used to help these machine learning models. It could be used to help create these applications that are kind of trapped in your mainframe. And this is one of the general use cases for why an organization would go more hybrid cloud, right? How are you best to get the mainframe data off? And traditionally, in the past, you would see people doing ETL operations, extract, transform, and loads to take the information that you've got, push it out in a big batch over multiple hours overnight, and then use it for whatever purpose you want. And then you would do that again every week or every day. And so, there's a lot more ways to go about it nowadays than that. One of which is through data replication, right? The idea of taking your data, say, let's keep it quite simple, and you've got some a DB2 environment on the mainframe, and you want that DB2 information on all those tables to be reflected over in your, say, your Postgres table over here on the distributed side or in AWS. The idea of capturing said data, transforming it into a universal format, and then applying it to your target is something that could be very interesting for your environment. Particularly if you're a customer that, say, you have a big contract with Amazon and AWS is your cloud, and you want a lot of information over there. Well, then maybe you want to start replicating your DB2 environment, IMS environment, your vSAM files, etc. And you can start doing kind of a many to one, or alternatively like a one to many replication sort of relationship there. And some of this stuff can get quite complex. DB2 is a relational database, IMS is a hierarchical database. So the whole process of taking a hierarchical database, transforming it into a universal format to then push it onto Postgres or Oracle or whatever your target is, can be, pretty difficult to do. So anyway, that's a big outcome that a lot of organizations in Europe are looking at today from my experience. Again, we can look at data virtualization, which we briefly mentioned earlier, and that's the idea of querying the data. So rather than moving the data off platform, let's keep it on the mainframe and let's query it, right? As you can then query the data through SQL statements, for example, and set up REST APIs to access the data. And you can change, or you can, even better yet, just read the data. So my application over here needs information from a DB2 table all the time. Well, then let's just expose the DB2 information to these applications, and then we can start building from there. That's an interesting outcome. And maybe you want to do something like offloading costs, right? I think one of the simplest use cases of cloud is, hey, I've got a lot of data, as Jeff said in the stat earlier, 35% of it, or maybe more, is kind of pointless. We keep it for regulations, or we keep it for whatever the case may be. Who knows? Maybe we should be keeping it, but we're keeping it because that's the way it's always been. And that's sitting in your data center on expensive disk, more than likely. And you want to get rid of that. You want to bring down some costs. You want to clear up some space in the data center. You want to reduce your electricity bill. You want to reduce your aircon bill. Things like that. They seem like small things, but for a large organization, that's a lot of money. What about just archiving that data to the cloud? Rather than having it sit on a VTL system, for example, why not just move it over to the cloud and have it sit there? If you're not using it anyway, the majority of the time, then that's just a simple cost savings, because clouds in general are quite cheap to keep data on, but get expensive when the data is constantly being recalled and requested, right? So that's an interesting outcome. And again, all of this sort of modernization outcomes can be achieved by understanding your data. So understanding the importance of said data on distributed side or on the mainframe side, collecting the metadata, understanding what's important and what's not important, and being able to track that is all very important outcomes.
So Michael, we've got about 18 minutes left in our time budget, and we've got some interesting and useful case studies to talk to. Why don't we press ahead?
Yep, that's me done.
Go ahead.
Yep.
And touch briefly here, and then we'll expand on how customers actually applied this.
Sure. Yeah. So I'll be quick in my sections because I more or less covered them. The idea of data intelligence here, again, like I said before, it's about uncovering trusted data sources across the entire IT landscape. You've got a diversified environment. You want to understand some data that you might not really fully understand. You can collect metadata records. You can use plugins and REST APIs to display and then understand how data relationships are built, data lineage, things like that. So we have a use case actually that Jeff is familiar with that we'll take you through just now.
I will. Thank you so much there, Michael. So Rocket is a global software provider. We operate in all geos outside of perhaps Antarctica. And so some of the examples we'll give will be from the States, with all apologies to those of you who are UK centric. And we start with how Huntington National Bank has applied the Rocket Data Intelligence. Huntington is a terrific success story. I actually started working with them in another line of business around electronic payments back in the 80s, and have watched their success as they've grown from a regional to a super regional, and now a true national bank in terms of their impact and their clientele. Well, the consequence of growing like that in banking in the US is a lot of acquisitions, smaller banks that have been brought on board who came from different sources of data processing, some of them on service providers, some of them who were hosted on MSPs, some of them working on in-house. And the consequence is over the last 20 and 30 years, the complexity of understanding their data has grown enormously. And in this last short number of years, they found that they needed to make a radical change to continue to be successful. They needed to better understand their data, and they applied the Rocket Data Intelligence for that purpose. It was able to automatically discover the data and help build a metadata dictionary that becomes the basis then of self-service development, application development for the really enormous number of both staff and contract engineers that they have working with their mainframe data. With this, they've been able to shorten their time to market and their time to practical use of new applications from many months to a short number of months, or in some cases, even weeks. Next slide, Michael.
Sure. So, speaking previously to it a little bit, the idea of data replication and then syncing is to take various disparate data sources, take, say, mainframe sources like IMS and DB2, capture, transform the data, and then replicate it in a either one-to-one, one-to-many, many-to-one, or many-to-many fashion to your various targets. For example, your cloud targets here. So we have another win story about this product. Sorry, Jeff, were you going to say something?
No, not at all. I'm waiting for my cue, friend.
No problem. No problem. But of course, this sort of technology is always very security conscious as well, right? So we're talking about encrypting the data when you send it off platform. We're talking about site-to-site VPN, staff controls, filtering in place as well. So again, we're still keeping on the same notion that I touched on earlier in that, we're not trying to expose your organization to any risk. We're simply just trying to make it easier for you to achieve these outcomes in scale as well. Sorry, one more slide here, Jeff. So, when talking about data synchronization and replication, you really need to consider what your strategy is. Is your strategy a coexistence, right? Which is what we're really kind of aiming for today, having a synced environment between your mainframe and cloud platforms. Are you talking about a migration when you're moving off the mainframe? And we hope that you, personally, hope that you don't do that, but organizations do that. And it comes with a lot of risk, and it's a difficult thing to do, but some organizations are choosing to do that. There's the modernization angle, right, of integrating new technologies like streaming platforms. Kafka, for example, is a big one in recent years. Or the idea of digitalization, right? The use of real-time data and data hubs. data lakes for big data analytical purposes and things like that. So it's definitely important to consider your strategy when talking about data replication and synchronization. So we have a use case story here about Vic Roads that Jeff will take you through.
And those of you who may be familiar, Vic Roads is an Australian case study. Victoria Road System is highly transactional dependent. And as they've grown and worked to manage the millions of transactions that they're processing monthly, they needed to go to a different architecture so that they could share all of that vast quantity of information with other systems in their architecture. And they looked for something that would allow them to synchronize databases between the mainframe, the primary system of record, and distributed systems within their architecture and on cloud. And by using the Rocket replication and sync offering, they were able to achieve just that, actual bidirectional sync between the system of record on mainframe and their other databases off platform. And as a consequence, the level of service they were able to provide both to the other agencies or departments of the government and to their customers in terms of providing up to the moment information that was accurate and consistent increased enormously. Michael?
Yeah, no, just a really good point you touched on as well is the idea of bidirectional replication. Everyone thinks, oh, let's take your mainframe data and replicate it to the cloud or distributed platforms to grow that side of the business. But if you're a mainframe-centric org, what about replicating back the way? What about making updates on the distributed side and replicating that back to your growing mainframe environment as well? Certainly helps with some modernization use cases.
It is a real-time change data capture. It does give the assurance that the data that you're working with on either system, mainframe or not mainframe, is current and up to date. And that's something that's been tremendously valuable to our customers. Please go ahead, Michael.
Yeah, no problem. I won't spend too long here, but there is a conflict for some people. Are you better to replicate your mainframe data off platform, right? So push the data to one side and then sync it accordingly, or virtualize your data. So expose the data sources to the cloud. Each come with their own particular benefits, but you can actually use them both in tandem as well. You can have your mainframe data syncing to the cloud whilst exposing some data to, say, mobile applications for use cases there. A lot of the case really here that you can actually wind up implementing could be for machine learning models, and particularly with the introduction of the new Z16 Telum chip with accelerated AI. This is a real modernization outcome here for kind of hyper modernization landscape. So organizations some of the trailblazers are implementing some of these in their environments today, but it's certainly food for thought if you're taking the first steps. And again, virtualization, we are talking about exposing data for applications for business intelligence reasons, or to have machine learning models get built up in data lakes and things like that. And the idea behind Rocket's data virtualization offerings is simply to keep your mainframe data in place in the mainframe where it's safe and cozy, but allow your other applications on the distributed side to query that data, right? So you can keep your confidence in your data as in the place you want it to be, but you can also, use it for various different reasons. And with integration with modern APIs and things like that, it's really quite a slick way to go about your business. And we have a customer story here that Jeff will take you through on that.
And while we can't name the organization here based on our relationship with them, if I mention it to you, it would be an immediately recognizable global financial services company, one that has been in market for more than 60 years and touches literally every country in the world. Now, through their growth, they were entirely dependent on mainframe for decades. And as they entered the new millennium, of course, started augmenting their capabilities with distributed processing. And one of the things they found is they had enormous dependency on legacy or traditional mainframe architectures, such as VSAM, IMS, and others. And they had an enormous appetite for generating reports and other sorts of business intelligence from the data that resided on the mainframe. And the length of time required to generate new reports or new views or to apply new calculations to the data being accumulated in their transaction processing system just went up enormously. And as many did in the industry at that time, they began to put in place extraction, transformation, and loading, ETL processes. And that worked to a degree for a period of time. But over time, what they found is that the ETL processes were becoming, again, more expensive and certainly taking longer to implement. To implement a single database extraction into their distributed report writer system would take upwards of 6 to 9 months. To do it when they had to extract from multiple subsystems, say IMS and VSAM, it could take 18 months. By standardizing on one productized tool that already had integration with all of those mainframe subsystems and could easily virtualize the data and export it to their distributed systems in formats that were SQL friendly, they were able to reduce that from many months to a month or 6 weeks or less to generate new reports that their executives needed to run the business. Michael, next slide.
No problem. This is the last one, and it's really about the idea behind taking your VTL data, your cold data in general, but not necessarily always your cold data, and offloading that to the cloud. And this will almost always be for cost reduction purposes, but could also be for disaster recovery purposes as well. Maybe you want a tertiary site of your mainframe copied over into the cloud that can be recovered if needed. So that's the general idea behind Rocket's Cloud Connector offering. Moving data over to AWS, Azure, or S3 devices as well, such as your Cohesities, Pure Storage, etc. And one last customer story here, Jeff will take you through.
And so I'm really quite close to Rocket Cloud Connector, and again, this is something that I'd encourage every enterprise to look at, again, because of the competitive environment. We all look for ways that we can make the best use of the budgets that we get for our mainframe operations. And certainly one of the complaints we've heard is that the volume of virtual tape hardware that was being required to store what I have profiled as worn data. Most of us are familiar with worm, write once, read many, but there's also a category of data called worn, which is write once, read never. And this is what we focus on. It's the secondary data that is touched seldom, if ever. It is incremental backups. It is records retention data. It is the mountains of data that we may be required to maintain based not on our legal or counsel advice, but on regulation. And if this data is being placed on expensive virtual tape disk, it's costing 10 times more than what it may cost to store it on a cloud. And so we have a means by which you can, without changing any JCL or any workflows, have that secondary data be directed to be stored on the cloud and can be recovered from the cloud with the same processes. There's nothing that the mainframe recognizes about the destination or how the data is stored that makes it look any different than as if it were on a virtual tape library. This is something that can greatly help ease the pressure on mainframe budgets around storage. Michael, we have just a few moments. We should probably go into wrap up and ask if there's any concluding questions. I'll take this. So we do encourage you, if you have not taken a look at Rocket, we have the global scale, we have the usability of mainframe offerings, the breadth of features, and the opportunity to help you both improve your operations and reduce their costs as you look forward to your mainframe future. With that, Michael, can we just open to questions?
Yeah, I think that's us done anyway. So, yeah, any questions, please put it in the chat. We have a couple more sessions as well coming up. I think one down here in the bottom right, which is talking about data recovery by Rod Dyson. That's in about a half an hour from now. But yeah, please put in the chat any questions, or unmute yourself if you can. Otherwise, you can always email us, and I'll put my email in the chat.
And we would be remiss without, if we concluded without reinforcing Anji's words, please do fill out your response to this. We are keenly interested in what we collect in the survey to learn not just if we get pats on the back, but much more interested in your critical thoughts and how we can make these sessions better and more useful to you as we go forward. Michael and I both have thick skin, so we welcome tough love.
Yeah, don't hold back.
Matt, thank you for your kind words. And Colin and Sridhar, thank you for your contributions as well. Anji, over to you, I think.
Yeah. Well, I find that very interesting. Thank you both very much for that. And as you said, feedback, please. Session was 1C, I believe. And let me just check that. 1C. Yeah. So please do that and look forward to seeing another of your sessions. Thank you all and enjoy the rest of the conference.
Cheers all.
Thank you.